Welcome to Future Legacy.
My name is John Ely. I am a technical program lead at Google ATAP. Project Tango is a journey that we've embarked upon over the past 18 months with universities, research labs, and industrial partners to build upon the last decade of research in computer vision and robotics, concentrating that technology into a very unique mobile device.
When you're outdoors, you can use your cell phone and you can use GPS and find where you are and where you want to go. When you enter, the moment that you enter a building, GPS is not available anymore. So we need to create other ways for being able to find where we are.
Project Tango is producing a solution to the visual navigation problem for how devices can stay localized in 3D space.
I did the research initially that developed the 3D vision algorithms that the rovers use to drive safely on Mars, and I worked on that as a grad student in the 80s, and then I came to JPL, and then it turned out that Tango is similar in that you've got this device in your hand. You need to know where it is. One of the best ways to do that is to use the camera in the device to track features in the room.
The problems we encounter in that research are the same problems we're struggling with now in our autonomous driving project and in the Project Tango, which is how to re-recognize places that you've been before, even though the environment has changed.
We have runs throughout the DC area where Project Tango is recording all of the visual and also inertial odometry information from the vehicle, and then we use that to experiment on localization algorithms.
So our team at ETH is working on search and rescue using small UAVs.
When first responders arrive at the scene, they often want to get a map of the environment because buildings are destroyed and previous maps are not valid anymore.
So my team is contributing a number of different algorithms to Project Tango. In particular, we're looking at making it possible for Tango devices to also work outdoors in terms of capturing depth information.
So one big goal we have at ETH Zurich is building a map of the city and the lake area. I'm very enthusiastic about bicycling, so the natural thing to me was to mount the helmet with the phone and to just go through Zurich.
We actually feed that into our maps and build these big maps together that all the robots can use.
Once navigation and perception is solved for a single robot, you can combine it for aerial vehicles and ground vehicles and can all co-localize in a common map.
And so it's a very exciting thing to try to be part of because you'll be able to have a very large impact for computer vision and robotics and 3D modeling.
We were working very closely with Johnny Lee. I was fascinated by the way he brought in all specialists from robotics, like navigation and perception and calibration. He got the experts from all fields and brought them together to build one device.
We've been able to work in collaboration with universities and other industrial research labs to push the limits of physics and push the limits of our human knowledge to achieve much more than we could alone. And I want to work with the developers who are excited about doing more than a touchscreen app and help us explore this journey. And as we evolve the hardware, we are excited to see what the developers will produce.